everyone, and thank you for joining us for today's webinar. My name is Neil Foley, and I'm the Applications Engineer here at RIZE. Today, I'm going to be talking about implementing fine resolution, the way that it's implemented with RIZE software. So I'll be going over some of the benefits of using fine resolution and also some of the important considerations to look at before using it. So first of all, here are some of the basic things you need to know about using fine resolution. First, the RIZE software that we offer has two possible vertical resolutions, and those are called fine and standard. So fine resolution has layer heights of 125 microns, and standard resolution has twice as much thickness per layer at 250 microns. So this is only the vertical resolution. The horizontal resolution can be much higher, but it's also limited by the minimum thickness of individual toolpaths, which is approximately 400 microns. So some of the things that using fine resolution can help you to accomplish is to improve surface finish in some cases, as well as resolve finer features than you could achieve with standard resolution. However, some of the things you'll need to consider include the fact that using fine resolution will result in a slower print speed because you'll be printing twice as many layers at just about the same speed. And it also results in a higher extrusion pressure because there is less distance between the extrusion nozzle and the plastic layer below that is being extruded into. And so this pressure can result in a variety of different challenges depending on the type of geometry that's being extruded. So now I'll go into a bit more depth on the different benefits that you can achieve from using fine resolution. The first major category is having the ability to improve the surface finish. So depending on what surface you are interested in improving the smoothness of, changing to using fine resolution instead of standard resolution may or may not have a significant or minor effect. So the best places to be using fine resolution are shallow slopes or non-vertical curves. So essentially places that have very visible stepping that results from the layer lines being resolved in a way that you can see the separation between each layer. So this would happen on any surface that is close to horizontal but not quite horizontal. It's not so much an issue on surfaces that are close to vertical but not quite vertical. It's only those that are close to horizontal. Now, on the other hand, switching to fine resolution will have only a very minor effect on the surface finish of vertical walls or vertical curves. This is because most of the non-smoothness in the different surfaces on a part will be on the portions that are more at a diagonal rather than either horizontal, where the thickness of a layer is not really visible, or vertical, where the thickness of a layer is already fine enough that vertical walls tend to be quite smooth. So the other major benefit that you can get from using fine resolution is the ability to resolve finer features. So this can apply to a variety of different cases. One of those would be improving the accuracy of vertical dimensions. So because you have a number of layers that can only be an integer value, you are limited by the 250 or 125 micron resolution provided by your layer heights. So if you have a vertical dimension with a certain tolerance requirement that falls within a range smaller than your layer heights, then in some cases it can be helpful to use fine resolution to allow you to get closer to the actual vertical value that you're aiming at. Another thing that using fine resolution can help with is producing higher resolution markups on vertical walls or steep slopes. This is because in some cases having a markup on a wall can split the markup into horizontal lines along the layer lines that makes it more difficult to discern either what text is saying or what an image is supposed to look like. So by increasing the resolution to be fine can increase the number of layers that it's being split up into to twice as many, and that will allow you to resolve the text and images much better. And finally, something that fine resolution can help with is to better define shallow reliefs. An example of this would be engravements. So similar to the vertical dimensions that can be aided in this regard, if you have a small depression on the surface of a part, particularly a top or bottom surface, then if that depression is shallow enough, it may not even show up during slicing. If it's shallower than 250 microns, then it may not be split into its own layer. It may be smoothed over during slicing. And so using fine resolution can allow you to resolve more features like that, particularly very shallow engraved text. So next, I will discuss some of the limitations of fine resolution, some of the things that you'll have to pay attention to when deciding whether or not to use it. One of these, as I mentioned earlier, is the increased extrusion pressure. And some of the problems this can cause include striations on narrow walls. So if you have a part with narrow vertical walls, then as the part is built, you are applying a lot of pressure from the extrusion head onto the top surface. And if the wall is narrow enough and the extrusion pressure is high enough, then this can cause the wall to buckle, and that will create some amount of oscillation. And you may see these oscillations in the surface of the part as the layer lines seem to move back and forth. So, of course, using fine resolution is going to increase the extrusion pressure, and so you'll begin to see these striations on less narrow walls than you would have using standard resolution. Another factor that can affect that is the height of the walls. If your narrow walls are quite short, then it may not be an issue, but if you're building tall parts with narrow walls, then you're more likely to see that effect, especially near the top. So another thing that extrusion pressure can affect is the self-supporting build angle. So if you have a part that's building with a sort of overhang, but with a self-supporting build angle, then typically you can build at approximately 45 degrees with no trouble. However, with increased extrusion pressure, this angle is often not good enough, and you may see material pushed out the side because it doesn't have a full base over which to build each layer. So it's best to, if you are looking to create diagonal overhangs, you may want to decrease or rather increase the minimum self-supporting build angle in your advanced support options. And lastly, regarding self-supporting overhangs, one of the effects that the higher pressure can have is that it exerts more torque on the moment arm of the overhang. And so if you have a very small footprint, for example, if you have a sort of inverted pyramid shape that you're printing, then as the extrusion head prints on the outer edge of it near the top, you're going to be exerting a lot of torque at the narrow base of that part. And that effect is increased using fine resolution, and so you're more likely to see parts get knocked over if they're tall enough and have narrow enough bases. So another thing that limits the use of fine resolution is that it becomes more prone to thermal contraction or warping, and this is because it's extruding material much more densely into the part and pressing much harder into the existing thermoplastic layers, and because of that, the plastic, as it contracts, is exerting more stress on the thermoplastic that's already been laid out, and that can increase the effect of warping. Another effect is that it slows down the prints, often to about twice the duration, and so if print speed is something that's important for your part, especially if it's a part that's intended to be printed multiple times, then this may be something that should dissuade you from using fine resolution. And finally, using fine resolution is only going to improve the surfaces mentioned on the previous slide to any noticeable degree. Those are the shallow slopes, the curves, and to a lesser extent, the vertical surfaces. It will not have hardly any effect on horizontal accuracy or resolution. So in some special cases, it can improve horizontal surfaces, but this is more a side effect of different ways that fine and standard resolution are sliced, rather than an effect on the way that it's actually printed out. And that's not a very reliable effect. So typically you should not assume that using fine resolution will improve a horizontal surface. So now we'll look at some of the specific things to consider when deciding whether or not a certain part is a good one to use fine resolution on. So some of the requirements of a part or an application that should persuade you perhaps to use fine resolution include the requirement for a higher surface quality, as well as having more accurate vertical tolerances, as well as having better resolved fine features, and also having smaller or more precise vertical markups. Now, notice that all of these are comparisons: higher, more accurate, better, smaller. There's no absolute definition of where fine and standard resolution should be used. It should always be a comparison between what you're able to achieve with standard and what you actually need to achieve. So in a lot of cases, having a higher surface quality is nice, but depending on how much higher you need it, you may not in fact need fine resolution, and it can often be better to stick with standard resolution to avoid the challenges posed by fine resolution if you don't really need a significantly higher improvement. So some of the features that may be present on a part that should also persuade you perhaps to consider using fine resolution include, as mentioned, shallow slopes, non-vertical curving surfaces, shallow reliefs and engravements, and fine features requiring vertical precision. Now, here are some of the applications or features of parts that should persuade you to avoid using fine resolution. The first of these is, as mentioned, short printing duration. So if you need to be able to print a part quickly, or you need to be able to print many of a certain part, then using fine resolution is going to slow you down quite a bit. Some of the features that should also dissuade you include narrow walls, especially if they're tall, parts that have all orthogonal surfaces, such as the part shown in the image here. You have vertical walls and horizontal walls, but you don't have any curves or slopes, and because of that, using fine resolution for this part would have hardly any effect at all. However, it would likely cause a significant increase in print duration and possibly some other negative effects if used improperly. Some other features that you'll want to try to avoid using fine resolution on include barely self-supporting overhangs. One solution to this is, as mentioned, increasing the minimum self-supporting build angle in advanced support options. Also, parts that have narrow bottoms and wide tops, which produce long moment arms, such as the pyramid example that I mentioned. And finally, parts that have bulky volume or large footprints. Having bulky volume or a large footprint is something that's more likely to result in warping on a given part. So now I wanted to talk about some of the things you can do if you find that you do need the improved surface quality or improved feature resolution of fine resolution. However, there are aspects to your part or application that suggest you should not use it, or that you have been using it and it's been having some trouble giving you the result that you're looking for. So shown in the image here are 3 different prints of the same part. The first print is a part of a sole of a shoe. So it has very sort of organic curved surfaces, and that was printed at 250 micron resolution. So that's our standard resolution. Then in the middle picture, it's the same part printed at 125, our fine resolution. So you can see that there are twice as many layer lines, and this makes it a bit smoother. So that's a positive effect. However, an even better approach is the last picture, which is using standard resolution back to 250. However, the part was reoriented so that this surface, rather than being a shallow slope that's close to horizontal, is instead a very steep slope, close to vertical. So this just involved rotating the part upward 90 degrees so that it stood upright, and that eliminated all of the stepping on the bottom and significantly improved the surface quality of this part. So that's one way of improving the surface quality, reorienting it to eliminate the shallow slopes. Another option is to try smoothing the surface with sanding, tumbling, or delamining, or a combination of those. So often you'll want to try to choose an orientation that will optimize either the surface quality or a set of other factors, and then something like sanding or smoothing should be secondary after you've already exhausted other options. So some things that you can do to accurately resolve fine features and vertical dimensions include, again, reorienting to get critical dimensions to face a horizontal position. You can also get engravements and other fine features to reorient so that they're on vertical walls rather than horizontal surfaces. This is because, sort of as shown in the images here, it can be easier to get high quality surfaces and more resolution using the vertical walls rather than horizontal. And finally, regarding markups, it's sometimes useful to replace the markup onto a horizontal surface, a fully horizontal surface rather than a slightly sloping one, or to reorient the part itself. And this can help eliminate some of the stepping that might be reducing the quality of a markup. So here's sort of a general discussion of how to consider these different ideas when deciding whether or not to use fine resolution. So you should use fine resolution only if the real benefits of fine resolution are required by your application. So this is not just that you would like perhaps to have better surface quality, but that it's required and that there aren't better options available. You'll also want to make sure to only implement fine resolution if the well-suited use cases are present and poorly suited use cases are not. So if you have a lot of well-suited use cases and even one poorly suited use case, that may be enough to render using fine resolution more trouble than it's worth. Another thing is, as discussed on the previous slide, you'll want to take advantage of any alternative solutions to get better surface quality or feature resolution. Even if you are also using fine resolution, it's best to try to combine factors in order to get the best combination of things. And finally, it's good to consider the limitations of fine resolution and adjust your approach appropriately. So if it's possible, it is often good to take the narrow walls that would have caused trouble and striations and thicken them so that they're not as susceptible to oscillating under pressure. Also, you can look to orient parts to reduce warping and improve the speed of a print. You can increase the minimum self-supporting build angle for overhangs, as I've mentioned a few times, and you can use honeycomb fill rather than solid fill to reduce the effect of warping, which tends to be more severe on solid infilled parts. So that's everything I have on the topic of implementing fine resolution and best practices. So I'm going to stick around for a few minutes to answer questions. If you have any questions, please type them into your GoToMeeting chat window and I'll answer them as they come. Other than that, thank you all for joining our webinar today. As always, you can reach me with off-topic or on-topic questions at applications@rize3d.com. Thank you. All right, I got one question regarding using fine resolution for carbon material. So currently, our carbon material is in beta release, and as part of that, we don't yet offer fine resolution for use with carbon. This is just because we are so far focused on getting the carbon material ready to release in a standard form, and so we haven't put the work yet into optimizing it for alternative approaches like using fine resolution. So a lot of these things will likely apply to carbon material in a similar way. Some of them certainly will be different, such as warping. Warping is almost not a factor at all with carbon material, and so you'll have to worry less about using fine resolution with large and bulky parts. But other than that, a lot of these same things will still apply, especially regarding things like producing small indented features that wouldn't have resolved at 250 microns. All right, it looks like no one has any more questions, so we'll wrap it up here. Thank you all once again for joining us for today's webinar, and please have a nice day.